Hello everyone, my name is Yesai Sumandreddy. I am from EC branch. My subject name is Engineering Physics. My topics are electric dipole, dipole moment, dielectric polarization, dielectric polarizability. Here we can see the introduction of an electric dipoles and dielectric materials plays a significant role in the electronic mechanism and material science. The presentation will cover electric dipoles, dipole moment, dielectric polarization and dielectric polarizability. Here we can see what is an electric dipole. Definition: an electric dipole consists of two equal and opposite charges separated by a distance. Here we can see the key points. It represented by a pair of charges, that means positive and negative charge. An electric dipole represented by two charges, one is positive charge and negative charge. It is a vector pointing from the negative charge to the positive charge. It defines the orientation of the dipole. When we can place a vector from negative to positive charge, it defines an orientation of the dipole. The dipole is characterized by its dipole moment. We can see what is a dipole moment. Dipole moment is represented by P. It is a vector quantity that measures the strength and orientation of the dipole. Here we can see the formula, where P equals to Q into D, where Q is an magnitude of this charge and D is an displacement vector from negative to positive charge. Here units are coulomb meter. Now we can see what is an physical significance of dipole moment. Interaction with electric fields. When a dipole moment interacts with electric fields, a dipole experiences a torque when placed in an external electric field. Here torque is given by tau equals to P into A, where E is an external electric field. Here we know the polarization. Dipole contributes to the polarization of material when placed in an electric field. That means when we can place the dipole in an electric field, it contributes to polarization. Here we can see what is an electric materials. Definition: a dielectric is an insulating material that becomes polarized when exposed to an electric field. When we expose a dielectric material to an electric field, it becomes a polarized light. Here we can see any types of dielectric materials. They are solid, liquid, gases. In solid types, glass examples are glass, rubber. In liquids, we can see the example water. In gases, air. Illustration show the effect of an external field on a dielectric material. Now we can see an dielectric polarization. Definition: polarization is the alignment of dipoles within a dielectric material in response to an applied electric field. Here we can know the key concept. Polarization refers to the displacement of positive and negative charges within atoms or molecules. That means we can see the polarization between the displacement of negative charges within an atom. Now we can see the mechanism of polarization. There are types of polarizations. Electronic polarization, the displacements of electron counts related to the nucleus. And the electric polarization means ionic polarization means relative displacement of positively and negatively charged ions. And the oriented polarization means alignment of permanent dipoles in the material. And the interfacial polarization means movement of charge carries at the boundaries of material. That means when the electric charges are move around the boundaries of material, it leads to an interfacial polarization. In we can see the what is an electric polarizability. The first one is definition. Polarizability is the ability of material to form an electric dipole moment under the influence of external electric field. When the material of an electric dipole moment is placed under the electric field, it leads to a polarizability. Here we can see the electric explanation. When a dielectric is placed in electric field, the positive and negative charges within the material shift slightly, creating a dipole moment. Here we can see the formula where P equals to alpha E. P is an polarization, alpha is an polarizability, E is an electric field. Now we can see the polarizability in different materials. High polarizability. Materials with a low band gap like organic materials tends to have higher polarizability. That means we can see the higher polarizability in the materials with which having a low band gap. Low polarizability. Material with tightly bounded electrons such as low polarizability, such as metals. We can see the low polarity in metals. Relative to permittivity. The material's response to an electric field is quantified by its relative permittivity, which is related to the polarizability. Now we can see the applications of dielectric polarizability. In capacitors, polarizability dielectrics increases the capacitance by reducing the effective of electric field. Now, that means polarizability decreases the effective of electric means to increase the capacitance. In insulating materials, high polarizability material serves as insulators. That means polarizability is high in the materials. It serves as efficient insulators. Optical properties. Dielectric with high polarizability can be used in non-linear opticals for devices like modulators and switches. Thank you.